What if I tell you can build a simple Arduino circuit to display CPU and RAM memory usage just by using a few cheap components? Hello, this is the Frugal Engineer, and in this video I will be showing you how to build and code this simple project. We just need these basic and cheap components: an Arduino board, 4 cables, and 16x2 liquid crystal display, the version that has the i2c bus module. We will see why during the next part of the video. We will need, of course, the last version of the Arduino IDE and Visual Studio. I have the 2022 versions, but you can use whatever version compatible. Now, let's see how it works. This is a general integration diagram between all the different pieces. We have in the middle the Caesar program. As you can see, I will be using two main namespaces that will provide the necessary classes for a project. We have the system.diagnostics. This namespace contains the classes that will allow us to get the CPU and RAM usage. Then we have the ports namespace that I have shown in different videos. I will show a link to that video if you want to check it. This one contains the classes to write and read from the serial Arduino port. We will review my simple program in the next section of the video. So in a summary, part of the Caesar program will read the usage from the CPU and will write those results on the serial port. Next, let's review in detail the Arduino diagram. As you can see, we will only need 4 cables to complete the setup: the ground connection from the LCD to the ground connection from the Arduino, the VCC to the 5 volts connection in the Arduino, the SDA, that called the data line, to the A5 analogic port in the Arduino. Finally, the SCL, the clock line, connected to the A6 port in the Arduino. As you can see, we are using an LCD screen with an i2c module. This module will allow us to simplify the connection with LCD screen that will allow us to focus on the code development. Basically, it works as an intermediator between the LCD and the Arduino. Before I start working on Arduino code, we first need to get the i2c address. When you are going to see the i2c modules for your Arduino projects, sometimes the manufacturer didn't give the address of the i2c device inside the chip. It can be a serious problem if the address is unknown or you write the wrong address. The scanner will cycle through all the possible i2c addresses, and once it receives a response from the device, it will inform you of the address to work. Just run this simple code that you see here on the screen, and in the serial monitor it will show you the exact address of that device that we will use in the next step. Of course, you will find this code on the description below. Just follow the link to the Google Doc document where you will be able to copy and paste the code. Okay, let's review now together the main Arduino code that will take the values of the CPU and RAM usage and display it on the LCD screen. The first thing that we need to do is to include the liquid crystal library. For doing that, we'll just need to include the library from the managed libraries here. I will let the exact name of the library on the description below, so you can just search it and install it. Then what we need to do is to set the LCD address to the position that we got from the script that I just showed you. Then a few variables that we will need later. In the setup function, we will just set those values. Obviously, we will need to read those values through the serial input. Then when we start in the loop, we'll do a few things to read the elements that we are reading from the serial input. First thing, I declare this variable, this complete word. It will make sense in a moment. Then I have a loop here. What I'm doing in this while loop is reading character by character from the serial input. Then what we do is to detect if this the new line symbol, we might not want to get that symbol on the LCD screen to avoid problems with the encoding. Basically here what I'm doing is just building that complete word string if the complete word, because when we finish here this while loop, I will check the values of that complete string. If it only contains the word "the", I realize that I want to execute a function that is called clear, and this clear function, what it's just going to do is just going to call the LCD clear function, and will allow us to get to remove all the contents from the LCD screen. If not, if the complete word is different than empty and is not null, then what we'll do is I will find the index, the exact position where this symbol is, this pipe symbol, because I will show you what I'm doing in the C# code, but I'm sending the CPU usage and the RAM usage in the same strings. It's a little bit easier for me to control it, and I separate both values using this pipeline. Then get the length of the complete word, so I know how many characters I have, and then I divide the complete word into strings. The first part will contain the CPU load, and the second one will contain the free RAM. Then finally, before that, I do a clear that allows me to remove any content I have on my screen before printing anything. Then I set the cursors to the first column and the first line, 0, 0, write the CPU load value. Then I go to the next line, and then I print the free RAM, and then this starts again, obviously with a delay of 2 seconds before I check before I start the loop again. This helps me to control how I send information from the C# code. All of this will make a little bit more of sense when I explain the C# code. Of course, you will be able to find this code in the description below, or if you have any questions, please leave your comments, contact me, and I will try to help you. Sometimes it's not the best to explain this on a YouTube video, but I hope it's useful. Okay, so let's review now the C# code that we will use to send the CPU load and free RAM to the Arduino. If you remember from the first part of the video, the C# program only has 3 main parts. The main, obviously the entry point of the program, the Arduino port class, and the PC stats class. Let's quickly review the Arduino port first. So the Arduino port class is the class that is in charge of reading and writing the information to the Arduino serial port. It's really simple, we have seen this in other videos, but just to give you a quick introduction, what we need to do is to create this serial port variable to just have this function creation here, where we send the port number and the baud rate that we will use to initialize and to open the port. And then we have just another function to read into the port the text that is passed as an argument. Here, if it's null and the port is open, we send it here. And then we have another function to close it. I am not using this program, but it's good to have it. This class, the PC stats, what we will do is we'll get the values of the CPU usage and RAM usage and return it as a string. What we only need to do is to use this class performance counter. We can actually do much more stuff than only getting the CPU and the RAM usage. We can see it in future projects. And then I just have 2 really simple functions, one for the CPU usage that will return the CPU usage, concatenating the percentage here, and then the available RAM that we will send as well as a string. Okay, so now with the classes out of the way, we can continue and finishing explaining the C# program. What we will do is to create 2 variables that will be instances of the classes Arduino port and PC stat. Then we'll have an infinite loop that every 2 seconds will get executed. We will get the CPU load here, the RAM usage here, and we will write in the Arduino serial port. Do you remember when I was showing you in the Arduino code that we had to split using the pipe? This is why. this is the best way or the easiest way that I found to use it. So maybe you will do it better, maybe you will use it another way, but in my case it was the easiest way. And this is how the Caesar program works. Of course, you will find this code on the description of the video below, and if you have any questions, just please ask me. With all the pieces in place, the only thing that we need to do is to execute the program and connect the Arduino. If you have a 3D printer, you can even create a nice shield for the screen. This project opens a door to an infinity of different experiments that we can do. Well, I hope you enjoyed this tutorial. If you did, please like and subscribe. Please also leave your comments with suggestions or ideas. As I said, you will find all the code and links in the description below. Thank you so much for watching. I will see you in the next video.